This software as a service solution must be able to process call recordings and, leveraging an LLM model service, which you can consider a black box, provide text-based summaries of each call. Hello, friends, and welcome back to NextPath. I'm Robby, and we are back today with yet another system design mock interview and coaching session. Today, we've got another badass software engineer who's at the senior level. She's going to be designing for us an audio LLM pipeline. The idea here is we are working with a company that runs a ton of different call centers. Imagine that they are going to take those call recordings, they're going to send them over to our system, we're going to transcribe them, we're going to then be sending it off to an LLM to get it summarized. And the requirement is that within a minute of that call ending, we want our users to be able to see a transcription and summary in a UI where they can go and review and for quality or training purposes, whatever. In this system design, we're going to be working with a lot of very difficult concepts, including the transmitting, storing, and processing of large audio files. We're also going to be using LLMs as a black box. So again, working with AI via an API. And we're also going to be talking about a bunch of different trade-offs that you need to make when you are working with these types of files, especially when you're going to be running asynchronous jobs to process them. How are you going to manage those jobs? How are you going to report on those jobs? There's a lot of things that we don't get into as well. So what I'd encourage you to do as you're watching along is go ahead and do your own design on the side. Grab a piece of paper, grab a whiteboard, use Excalidraw or another virtual whiteboarding tool. How does your design differ from the candidates? What's similar? What kinds of constraints can you add? Are there other topics that we didn't get into that you would want to hear about or you'd have takes on? If so, would love to hear from you in the comments. Let us know. And without any further ado, let's get into it. Okay, so let's get started. So I have a prompt for you. The prompt I prepared is this. I'll read it off. I want you to design an audio transcription pipeline for a call center. This software as a service solution must be able to process call recordings and, leveraging an LLM model service, which you can consider a black box, provide text-based summaries of each call.
Okay. What will be the scope of this service? So, how many different end users are we gonna have? Is it gonna start with like 10? Is it like business to business? Is it going to be
That's a great question. Why don't we start with considering that there's about, say, like 1,000 different call centers that we're supporting, and we can maybe we don't have to get too much into the multi-tenancy of it all, but you can imagine that each call center is run by a different company.
um survey? Is there a black box?
Mm-hmm.
So I'm imagining because we're doing call, so these are just audio calls, not video calls.
Correct. Yeah.
Okay, that would affect the storage. And we have a LLM black box, so I don't have to think about too much of how that's working.
Yes.
Okay, so I would imagine obviously we're gonna have a front end, so a client, and that client is going to hit an API of some kind.
Mm-hmm.
And that API is going to be like an API gateway. And that gateway will include probably some DNS stuff, probably some load balancer stuff, but I'll get into that a little bit later.
Okay.
For now, I just kind of want to get the overall flow. So here's our actual API. And we want to be able to store this information. So there's some stuff that's going to be relational because we're going to have users, they're going to be different businesses.
Mm-hmm.
So that's going to live in a relational database probably.
Right.
Um, but we're also going to have these audio recordings. And these audio recordings are, it's probably good to live in blob storage. because there's going to be like larger files than just documents.
Correct.
So put blob storage here. So we have relational DB, blob storage, and we have our black box of the LLM. So that also is over here.
Mm-hmm.
So this API is definitely going to hit both the blob storage and the relational database, and is also probably going to hit the LLM model. And that's going to be a two-way street because we're going to get back information from there about the audio recordings.
Correct.
Okay, so we have the LLM, blob storage, relational database. Okay, so this is the basic flow, I believe.
Yeah, that sounds good from a high level.
Okay,
Are there
so
any
let's
other questions that you might have about the scale of the problem that would help you move forward?
scale the problem. How many um recordings are going to be processed at a certain time?
Do you mean
Because that,
concurrently?
yes, concurrently.
I'd say we can imagine, say we have about 20,000 concurrent calls on average, or even on peak, maybe. Might be more than that, but we can just go with 20 for now.
Concurrent calls. Peak more. We'll define what peak means later.
Yeah.
Okay. So that'll definitely affect how we decide to scale this.
Yeah.
Okay. So I'm primarily working at AWS shop, so
Mm-hmm.
I'm going to talk about AWS solutions for a lot of these things.
Great.
Um, blob storage will probably be S3. Um, relational database, if this is a SaaS company, especially if this is going to be a startup from the beginning, we want to use something that's cheap. Um, Options being like MySQL or Postgres. I like Postgres more because I feel like it's more feature complete than MySQL,
Yeah,
and
absolutely.
they're kind of interchangeable. So Postgres for the database. Um, this is still a black box to me. I don't know how that's running,
Mm-hmm.
but this API, this can be on an ECS instance that can auto scale if needed, um, and that will allow us to handle more calls if as we get them, so we don't have to worry about scaling as much.
Cool.
Um, and the gateway, we so handle DNS, load, I can spell, balancing. Um, According to I cannot spell. Okay.
That's okay. It's hard when someone's watching, right?
um, but I can also imagine if we have a bunch of users, we're going to want to make sure this is being handled quickly.
Yeah, let's talk about speed. What type of latency? What areas would we need to think about when we think about latency?
Um, we definitely, so for the product,
Mm-hmm.
people want to be able to know what the call said quickly. So the connection between the LLM and actually getting the text, what's it called? The transcription, that needs to be
Yes.
fast. Um, and I imagine people are going to also want to look at previous calls
Um,
fast, or
that
no?
would be useful. Oh, do you mean like during the call or just when they're going to look at it after the fact?
When after the fact.
Okay. Yeah, so we'd want recall to be, you know, um, near immediate, right? In the sense that like if
Mm.
I'm opening it up on a web browser, I'd want to be able to click on a call and not have to wait more than like a normal request cycle.
Okay, so definitely want to implement some caching.
Hmm.
Um,
Well, let's actually start with the let's start with the start. Let's look at the shape of the call. So you know how many calls you're processing roughly,
yeah.
but is there any other information about those calls that you might need?
Um, the so you're talking like the data model, or we're talking about like the length of the calls?
I'm thinking about the length, right? I'm thinking, yeah, because, obviously, if the call lasts 1 minute, that's going to be very different than a call that lasts 2 hours.
Yeah.
So I think a really important question here would be how long do we expect the audio to be? And how are we getting the audio, right? Like, for example, is your, I'm not asking you to implement a VoIP solution here.
Mm.
That's actually a bit of a hint. But the idea is, are you going to be getting streaming audio versus audio that's only accessible to your system after the call is complete?
Okay, so that's probably a question like how we want the system to work. Do the do the call agents want to be able to know, like, see the review of a call as it's happening?
Well, I would say no, that we can see the call when the call has ended. But
Okay.
these are questions that I would ask the interviewer because they're essentially constraints of your system, right? Like for example, you
Mhm.
can't control the average length of a call.
Yeah.
So I would probably tell you that as an average length of a call would be 15 minutes, let's say, or let's call it 30. Why not? Um, Maybe they're getting shorter with the use of AI, but I still think that humans should be doing these calls. So we'll say 30 minutes for the average length of a call, which um, now the question would be, do you have a gut instinct for how long a 30-minute, or sorry, how large a 30-minute audio file would be?
Depends on audio compression.
Mm-hmm.
So it could be completely uncompressed, like black format, and those can be much larger. 30 minutes can be around 50, 500, my bad, 500
Right.
megabytes, I believe.
Correct. Yeah.
Short call, uncompressed would be around, like a 3 minute call would be around 14 megabytes,
Right.
15 megabytes.
And do we need uncompressed?
Um, doubt it. We can definitely compress this to make like MP3 format.
Great.
Um, and that would turn the 50. I don't know on top of my head what it looks like. I'm thinking about um music files. I think that would get it down to around like a magnitude of 100, so I can like 500 to like 50
Yeah.
essentially.
Perfect. Yeah. I was expecting, yeah, it's about 40 to 50 megs for a 30-minute audio file.
Okay.
Um, and the other question that would be, again, because I'm not asking you to implement the phone system, is how does the data get to us? And we'll say that this is being streamed. So you don't need to worry about waiting until the call is over to have access to the data. Now, we don't need this pipeline to be completed. That's the
Hmm.
next question that I'd want to explore with you is, you know, again, it's kind of there are constraints, right, as far as how fast you can be, but I would want to have the candidate ask me, what are the expectations from a stakeholder as far as when the notes must appear in our dashboard or in
Hmm.
our and just to kind of preempt that, I would say I'd want to be able to see these summaries within about 60 seconds of the end of the call.
Okay. So summaries. Off. There we go. Okay. So in order to get that, okay, so we need to talk about how we're getting the audio. So the audio, I imagine, would be coming from a third-party service.
Mm-hmm.
Audio streams, and like we talked about, we don't need like the best audio, so we can have this be compressed.
Cool.
And I'm assuming it's being compressed in that from
Yeah,
the
we
provider.
can imagine that it's coming in compressed.
Okay.
Yeah.
And that would be also going through our gateway,
Mm-hmm.
because we want to like be able to tell where it's coming from and what is related and how it's related to different calls. So I don't want it to go immediately to blob storage. I want it to come through our system.
Correct.
Okay.
Yes. And then the question that I have now for you is, when we look at this,
Mm-hmm.
what do we think that looks like? What are the different protocols that we can use to get audio from the external service to us? And what are the trade-offs?
So I'm thinking like different ports. I know different ports are better for media, sending media versus sending like text documents. So like what's it called? UDP versus TCP.
Okay. Yes, it's an interesting concept. So now we're going down to the packet level. But when
Yeah.
we go a little bit higher,
Mm-hmm.
what are the types of like web protocols that are built on top of those um, strategies? Basically, what are the different ways that we can send media from one server to another?
Only thing that's coming in my head is streaming. But I know
Well,
you
okay, streaming. What are different streaming protocols that you know of?
don't know many. That's why it's gotten down to the pocket level. Cause I know
I
that
see.
when you're streaming like video and stuff, you want to send as many packets as possible, rather than making sure they're accurate or waiting to make sure they come in. So I know
Ah,
UDP is better for that compared to TCP.
yeah. So let's think about this. So let's say a I were to send an HTTP call. Why could I not just put the entire audio file into an HTTP call?
Oh, wait, I know something.
Talk to
There's
me.
something called M3 something something that breaks up streaming, so you're only sending chunks of it at a time.
Ah, chunked HTTP calls. That's one of them that I'm trying to get to. This idea of like you can send an HTTP call with data in it. And there's
Hmm.
two reasons why we can't send a single HTTP request, right? The
Yeah.
first one is somewhat obvious. It's stated in the problem. It's streaming data, so we would have to wait until the entire thing is completed before sending that call. So we don't have all the data. So we'd have
Hmm.
to send it in chunks, right?
Yeah.
The other reason is, can we fit, what do we say, about 50 megs into a single HTTP call?
Um, it's possible. It's slow.
Yeah, and it's unreliable. If
Yeah.
that fails, then
Then you feel the whole thing versus if you
right.
send it via chunks, it's you more likely for it to succeed in general.
Great. Now, what's one of the downsides to chunked HTTP that you could imagine?
Things come in out of order.
Okay. So we have to do some sort of consolidation.
Hmm. Missing chunks that can happen.
And how would we handle that?
You need to know which chunk failed in order to retry, and figuring out the model for that. So
Yeah, and that's where we kind of use that UDP style, like sending things multiple times, maybe.
yes,
What else do we have?
other things that can fail with this. So streaming audio.
What are some of the pros
Was it streaming the audio?
sorry, yeah, the pros of just sending these chunked HTTP requests?
Oh, they're a lot faster.
Yeah,
Um,
they're
again, more reliable.
faster. Sorry, go ahead.
It's faster. It takes up less bandwidth to send the chunks compared to having to send the entire file at once. And we can get the LLM
Yeah,
started faster on the previous chunks rather than waiting for the entire thing to be sent and brought back to the end user.
right. And it's also not a difficult build out because we're using HTTP. We're
Yeah,
It's a pretty simple protocol. So
that's what I meant by protocols. Oh, okay.
yeah,
I
what are
was
some
saying,
other protocols that we can think about when we're streaming data?
I know security protocols. I know like
I'll tell
TLS.
you, or even just technologies that we use to send streams of. I'm trying not to give you too much of a hint. Well, here's a little hint for you. One of the things that's also nice about HTTP is
Mhm.
that it's unidirectional, meaning we're only sending data from the third party audio collector to us rather than opening up a bidirectional uh, connection, which some of the other approaches would be bidirectional.
Like is it FTP?
FTP would probably, I think, only works if you have the. I don't think you can stream FTP, but I could also be wrong. I haven't touched FTP in a while, but I'm thinking of. Well, I'll tell you. I'll basically tell you the other ones I'm thinking of. Number one, there's WebSockets, right?
Oh, I didn't think about that for audio.
Yeah, because
Should
it's. And why? Tell me why would that work?
Because what's it called? WebSockets is a direct connection, and it's what's it called? You always once it's oh god, I'm not sure how to explain this. Once it's open, you get everything in terms of data, and it's
Yeah.
happening live.
It's persistent. It's a persistent
Yes.
connection. And so it's an upgraded, it's more difficult, or not difficult, but it's more complex than a simple HTTP connection because you have to upgrade to a
Hmm.
persistent connection. And it does have, and typically it's more overhead, which is the benefit of it is bidirectional, but we don't need bidirectional here.
Yeah.
They are highly scalable. Um, but because it is TCP, and I'm kind of giving you another hint here, it is higher latency than what I would consider to be the ideal solution.
Hmm.
So, are you familiar with a UDP implementation? I guess would be the word. Um, that is kind of like, well, it's an implementation on top of UDP that
Hmm.
allows you to send real time data.
I'm saying no.
Okay. So, what I'm getting at is WebRTC. Are you familiar with that?
No, not at all.
Okay, cool. So that's honestly not surprising, and I don't expect that people know that. Right here in the interview, what I'm doing is I'm trying to get to a place where you say, I don't know,
Hmm.
because I want to know how much you do know.
Okay.
And so you mentioned UDP, and so what that tells me is I was kind of already sold that you would be able to figure this out because you
Hmm.
would probably go and look up what is a UDP, like how do I leverage UDP practically. WebRTC stands for real time communication. And
Okay.
that's actually the industry standard for video and audio streaming. Um, It's UDP. It's a P2P. It's peer to peer,
Mhm.
and it's like super low latency and very efficient. But I will say that like it kind of scales.
Not well.
It's not that it scales not well. It's just that like there are scaling challenges that I don't think that we would encounter here. So for example, if we had group calls, like a lot of
Mhm.
different people joining, it could be a little chaotic and hectic. Um, but I think and it's easier to break that connection than something like a WebSocket. Okay,
Okay.
so again, you hung out in this conversation really well as we talked through these things. Like, I think you could logic your way through it.
Mhm.
So let's move on from that. So we have some way of getting the data from the audio stream to the API gateway. Once we get to the API gateway, what do we then we it goes through the API gateway, it goes to the API. What is the first thing that the API has to do with the audio as it's getting chunks or portions of it streamed to it?
As because we decide that we're going to go with chunks, we need to reconcile what order these chunks are in,
Okay.
and if we're missing any.
Okay. Let's say we can move past that. Let's say we know that we have the audio coming in and being
Okay.
streamed efficiently.
Okay. Cool.
So it's being streamed.
Hmm.
So what do we do with this idea of getting streamed data, or if you want to say chunked data to us? How do we handle that? What is the first thing that we have to do once we know that we are getting all of it, let's say?
We need to, what's it called? Put together and then send it off
Mm-hmm.
to the LLM.
Yeah.
And also send it to blob storage for long-term keeping,
Mm-hmm.
and also save the location of where it is in blob storage in our database.
So what is it that you're sending to the LLM?
Um, so this is where my lack of AI knowledge comes in. I know we want to send the call to the audio, and we're sending it with, and I'm assuming the LLM either already has its um what's it called, its prompt, or do you want to send it with a prompt?
So let's to oversimplify it, although to be honest, it's not too far off. Leveraging an LLM in a pipeline is more or less the same thing as using an LLM in a browser. You the difference is that instead of typing into a box your prompt, you
Mm-hmm.
send the prompt via an HTTP RESTful
Okay.
API call. So knowing that there's just an API call that you can imagine just takes whatever the body of that post is and it throws it into an LLM, or it throws it into like whatever your LLM, you can imagine it like an agent, right?
Mm-hmm.
What challenge does that face if we send the call audio?
The same one it had originally. We have this large file that needs to get to the LLM.
Yeah.
So now we have to worry about chunking again and all that information.
And what do we think the most expensive part of this, financially speaking, um, and computationally speaking? What do you think the most expensive part of this pipeline is so far?
Definitely this connection here to here.
Yeah. And so if we're sending, uh, is there a way that we can avoid sending 50 megs for every call to the LLM?
Yeah, we could, instead of, so while we already compress it, I'm not sure how much we take into account, um, what's it called, dead time,
Uh,
or that's not part of
I'm
this.
thinking, how can we get another order of magnitude smaller?
Another order of magnitude smaller. Do you just want to fully compress it like as a zip and it uncompresses in the LLM? I don't think that's gonna work.
Nope. I want you to zoom out a little bit. I think you're thinking,
Too granularly.
yeah, there's a how can we avoid sending the audio in the first place?
So we need the audio for the
For the what?
LLM to get the transcript. Once we get the transcript in a different way.
Yep, keep going.
Okay. Um, we could do a preliminary transcripting thing in our API.
Yeah.
And that transcript can then be improved by the LLM.
So two there are two stages to creating a summary of a call. The first is transcribing it. The second is summarizing the transcription, right?
Oh, okay. I forgot that part of it. Okay, so we are using, so we can definitely do the transcript on our own. So
Mm-hmm.
that can happen here. So now the audio is just in S3. We don't care about it. And then we only send the transcript to the LLM. And that's much cheaper because that's just text.
Correct. Now, couple questions I have for you.
Mm-hmm.
How would we implement, like, are you familiar with any of the ways that we could implement creating a transcript?
No.
Okay, cool. So there are plenty of libraries out there.
Mm-hmm.
Google has Google NLP, and there's plenty of libraries that'll handle this, and they're fairly simple. I would say that it's kind of the using an LLM would
Mm-hmm.
be getting a cannon to kill a fly,
Mm-hmm.
because it's a fairly solved problem and one that we don't really need an LLM for.
Mm-hmm.
So that's question number one. So basically, you can imagine that there's some external library. We'll just call this like speech to text.
Text.
Cool. Now imagine you have this library, and you can go ahead and, if you wanted to, you can install that. You can install that into your API server.
Mm-hmm.
What issues do you imagine we could potentially run into during peak times?
The server can get overwhelmed very
Absolutely.
quickly.
Yeah. How are we going to handle that?
You can separate out. You can, so there are many options to how to handle those kind of things. You could, in terms of figuring out which server is handling what. Um, you can always like do short tasks go to one, but that can also still overwhelm things because there can be much more short tasks than there are long tasks. So there can be a free server that's not doing any long tasks at all, but the
Mm-hmm.
short server is always going to be busy.
I
Um,
think you're dancing around this idea of different servers that have different responsibilities.
oh yeah, that's
What do we call
what I
that?
was getting at. But I was going about like how we separate out the servers. But
Right.
yeah, different servers have different responsibilities.
What do we call that? That architecture.
I don't know names for
That's
anything.
okay. That's essentially what we would refer to as a microservice architecture.
Oh yeah, microservices.
Yeah.
I know microservices.
Yeah, because otherwise, and I know when you're in an interview and you're like, I know the shape of this, but the word is just that one word is just not coming to me. It's totally understandable. So the idea here is that if we were to, put this technology into this server,
Hmm.
then if we get a couple things can happen. Number one, if we get a ton of calls, we have to scale this server up really large. Not really large, but like a lot of numbers of servers, a lot of numbers of instances of this server. If we do that, then number one, we're spending a lot of money. But
Hmm.
number two, each server that the load balancer is going to continue sending all requests to these servers. And so the servers are handling two things at once. They're handling the quote unquote short task, which is receiving the data and sending back a quick 201. And then they're also handling the processing. And then the question is, are you doing this synchronously or asynchronously? Are you spinning up daemon tasks? But you're essentially going to run into a situation where if you get a really big backlog of transcriptions, your CPU is gonna get pegged, and you're gonna start rejecting calls. You're gonna start like backing up basically. So it's the question is, how can we basically say, let's separate these concerns and scale differently?
So yeah, um, I'm gonna take your little thing here.
Take it. It's yours now.
Okay. So this is speech to text. So this is going to be the microservice, and that will be spun up over here, and it is bilateral. So now we have the text coming in and going back out. That's a microservice. What else can we get rid of from this? So summaries are, let me write this down. So this is handling summaries.
Right.
This is audio to transcript.
Mm-hmm.
And that then gets, so the API gateway is just shepherding different things to different places.
Right. So this is essentially acting as what we would call an orchestrator.
Yeah.
As well as a like front of house, like it's making sure that the it's receiving the audio streams. And now here's a question: when it gets the audio, when it starts getting audio calls, what does it do? How does it know? Oh, like, hey, I've got this audio. Now at some point I have to send it to transcript. Now at some point I have to send it to the LLM. How does it, what is that concept called of like, we're getting something to process?
You want to queue it.
Yeah. All right. Talk to me about that.
So, you know, Amazon has its, you know, I forgot the name right now. It has a queuing service.
Starts with a K.
You can basically, okay. Yeah, it's not gonna come to me right now.
It's okay. It's a kinesis.
Kinesis?
Yeah, which is just
Oh, but they also have SQS though.
Yes, they also have SQS. You're right. There's a couple of different ways we can handle this.
So basically you can have for every audio stream, it can be a ticket. I'm calling it a ticket just for like overall things.
Right.
And it gets queued for each portion of where it needs to go, but it only gets added to the next place after it completes the previous one.
Okay. So first off, good. Secondly, we would call it a job, basically. So we need some way of saying when we get the first packet, we need to know, hey, this is a call that we haven't seen before. This is a brand new job that we need to process. And so we'll probably want to tell the relational DB, you know, we'll have to have like some sort of a brand new job. We'll have an ID for it. We'll have some sort of like metadata, right? And then we'll need some sort of like status to track. And that status could be something like, you know, initiated. You know, it's up to you what's the word I'm looking for? How you want to like organize these statuses, but something like initiated, you know, like or like in call, summarizing, or summarized or whatever. Then what's next? Transcribing, something like that. You know. See, I can't spell either. But the idea is that you want something here that's going to orchestrate the job moving through the different states. So it's essentially like a state machine.
Okay.
And then this API is basically the one that is, oh, and then we'd also want to, you know, some sort of like, what is it? We need some, oh boy, I can't even type anymore. We need some sort of way of tracking like where it is in like an S3 key, right?
Yes, definitely.
So that, again, it ties it all together. Okay. So that's basically this API's job.
Yes.
Cool. Now, question for you. Let's say we get a ton of calls. Let's say it's lunchtime, and that's when people are, you know, calling because they're on their lunch break. So they go take their lunch break to call our call center because, you know, when you're bored on lunch and you're like, oh, I should just see how my friend at that call center is doing and just, you know, I need to talk to somebody. Anyway, so a lot of people are calling. We get a big spike. Do we want to I assume that we're auto scaling all of these microservices, right?
Yeah.
So do we just want to infinitely auto scale this guy?
Um, I would say no, because in terms of costs, auto scaling doesn't um what's it called? Isn't help our bottom line, right? We're not making more money by more calls we take, but we're making more money by knowing our systems are reliable.
Mm-hmm.
So we want to auto scale to the point of making sure it's still reliable, but not um, hitting us too much in terms of costs.
Yeah. So we need some way of buffering the flow of data from our orchestrator into this microservice. How would we do that?
So that just be another queue.
Absolutely. Throw it in there. That's really like when I think about queues, I think of them as buffers. As in my brain, I'm always thinking of like rivers, like, data flowing as a river, and lakes and all that. And I think of these as like the dams. The queues are the dams that hold it. They manage how much gets through, and they might even, process it along the way and generate electricity or whatever. So I don't know. That's just how I visualize it.
Queuing service. Um, okay, so it goes back to here. Yeah, now everyone gets queuing service. I just had like the thought, like, oh, it's like Oprah. You get a queuing service. You're getting
Yes. No,
service
that's
for all.
exactly it.
Okay.
Now,
Um.
funny enough, you have a queuing service to LM, and I don't hate that. But one thing
Oh.
that I don't expect you would know, but I'll just tell you just because we're here, is
Mhm.
that a lot of these LLM services, right? So, for example, at least I know that Anthropic has this. They have a batching concept where you can just send them data,
Yeah.
and as opposed to them immediately returning back with the response,
Hmm.
you can basically have it set up so that there's some guarantee that it'll be done within some number of hours, and you just
Hmm.
kind of pull them to say, hey, is it done, is it done? And so they essentially do the queuing on their end, and that actually usually results in a much lower cost per token.
Oh, okay.
But obviously, not knowing that, you put this queuing service here, which is great because that shows me that, again, you understand, hey, we don't want to overwhelm the LLM. We don't need it immediately. And so that's great. But also, again, we don't have hours, we have minutes, or a minute,
Yeah.
essentially. So that's great. Okay, cool. Before I start asking you more questions, how do you feel
Mhm.
about this design so far?
I'm liking it. I think it's
Yeah,
getting very interesting.
I think it is too. Are there any things that where do you want to go next?
Hmm. Do you want to talk about the data model? I don't think we need to talk about the data model. But I don't know why I feel like I need to be talking about
You
this
do.
end.
You do. There's a couple things that I'm thinking about.
Okay.
So let's talk about latency.
Hmm.
We we need to make sure that at the end of the call, we haven't really talked about like sequencing. As soon as the call ends, a clock starts, and we have 60
Yes.
seconds to get this thing into our system.
Mhm.
This thing being the summarization. What do we How do we want to make sure that that happens? How do we want to make sure that that fast path is available to us?
So now can I talk about caching?
Hell yeah, you can talk about whatever you want.
All right, cool. So we need our caching service back here. Um, and this can definitely hold our transcript
Okay.
as that comes in, and that can quickly go to the user once the clock is like being ticking,
Hmm.
and I think it can also grab the LLM summary and send it back to the user, um, and then it can process to the database later.
Interesting.
So the user can get the information as soon as possible, and we know it will be handled in the DB at some point.
Right.
Um,
Right. And even further, I mean, storing data to the blob storage. How quickly do we
yes,
need that data to go to the blob storage?
that's an
The audio.
event. I feel like it's an eventually thing.
Yeah.
Once, as long as it is getting processed fast,
Hmm.
it can get to its permanent place later on.
Right. So there's this interesting thing here where, sometimes when people look into this concept of CAP theorem, consistency, availability, right?
Mhm.
They will discuss consistency versus availability. Number one, as black and white. We either prioritize one or the other, which nothing's black and white in coding, um, or at least not in system design, I should say. I was gonna say yeah, because binary, it can be one ish, no, or zero ish, no. It's definitely black and white coding, not black and white system design. But also, a lot of people talk about CAP theorem in regards to the entire system.
Mhm.
I would draw a line through your diagram here that separates the fast path and the slow path. The one where speed is more important than correctness or consistency, right? Where availability is more important than consistency, and one where consistency is more important than availability. So we need to
Mhm.
make sure that the audio in the blob storage is like we're basically rebuilding the audio into the blob storage,
Yes.
right?
Mhm.
Or we're doing it, we could have a separate um, part of the pipeline that just takes, for example, when we get this audio stream, I imagine that you also, one thing that we miss is we're going to want to have a queue here
Oop,
at one point, maybe here,
oop.
I don't know, but it's basically somewhere that like we need to separate the ingestion from the processing.
Mhm.
And so we probably want a queue here that's like receiving. um Actually, you know what, I like the idea of this. I didn't mention this before, but I like the idea of putting another small service here. We'll call this our ingestion API
Mhm.
that receives this oy oy vey oy vey Excalibur, why you do this to me? um
Almost, I was very impressed at how you did that, but then it did not work out.
Yeah, I love how you're like impressed, and then oh my god. Okay, yeah. All right, all right. So here, I'll do it. I'll do it. So I'll put this here. This is our ingestion API. Um, you know what? All of you just go over here for a minute. Thank you. Goodbye. And then let's take this and stick it over here. And then this goes over here. Okay, so we have our ingestion API, and this is going to shove the audio into a queue. And the reason why I actually like separating ingestion from the orchestrator is because as
Mhm.
soon as like, let's say we're getting API calls that are HTTP. If it's doing HTTP chunking, we want to send back an immediate, just like quick 201. If we're doing WebRTC, we need. It's a good idea to just have another server here that is handling that ingestion and
Mhm.
managing the connection, right? Uh, Throwing the data into a queue, and then that queue, like as, and maybe making a call over here to say, hey, guess what, we've got a new job. And then
Mhm.
this is our orchestrator here that's handling the actual orchestration. So I'll just put queue here. Oh, that's not a queue, that's a queue. And then this is the API that's handling the orchestration. So this isn't even really an API, it's really more of an orchestrator, we'll just say. um, and that's reading off of the queue. So maybe it's doing that. So it's like a consumer. And then there can be another consumer that is sending that directly to the blob storage. So maybe that's like a Lambda, you know,
Mhm.
or whatever. So, it's not, obviously it's not gonna go straight from the queue. We'll put like a Lambda. I wish I could type a Lambda signal or sign, but I can't. So, All right.
There's
So
definitely some shortcut for it.
there's got to be, but all right. So now there's something that interesting that we can do here where we can indicate that, like, for example, this is a low priority,
Mm-hmm.
right? And so we can separate low priority from high priority. For example, getting it into the speech to text, getting it transcribed, sending the transcription to the LLM, getting the LLM transcription into the relational database or a cache, whatever, like you were saying, that's kind of a high priority.
Yeah.
Um, Another thing that I think is important to think about is ordering, right? So, for example, if I were to draw down here, let's say, just to go with like this idea of chunking, or even if we don't do chunking and we do RTC, we would want to basically chunk ourselves in the ingestion layer.
Mm-hmm.
So let's say this is an audio file and there's 4 chunks of it, right? And we can even just like say this is just like minute 1, minute 2, minute 3, minute 4. Do we wait until here to send to the transcription?
Oh no, you're sending chunks by chunks as they basically you're
Right.
sending the maximum amount per chunk every time you get to it. So
Maximum
when
amount.
minute one's done, send that off, have it
Yes.
start getting ingested, and
Yeah.
then everything else.
Because we don't need to look back and forth for transcription.
Yeah.
Okay. And then when do we send it to the LLM?
For the summary, when the full transcription is done.
Mm-hmm. Yeah. And is there a potential that we can get data in and out of the LLM faster?
Um, Potentially if we send a similar way we do the transcript, sending the audio chunks, we can send text chunks. But I'm afraid of the content, the summary. Sorry, I got a phone call. You can cut that.
That's
But
okay.
I'm afraid that the content um, not being properly connected, so the summary's off. So I want to have the full transcript
Mm.
done before I send it to the LLM.
I understand. So I understand your concern. What I want, what I, and this is a Robby thing. So what I mean by that is like, this is what I would want to hear, but I just want to be careful to note that like um, not all interviewers are going to want to hear the same exact things as me. Um, I would want to hear there is a risk that if we send chunks one at a time to the LLM, that it won't give us that it will confuse the LLM. But I want to hear that there's an option for experimentation here, because when we send things to an LLM, the point is that we provide context in the form of a prompt, right? So, for
Mm-hmm.
example, if we say, here is a portion of an audio summary, more data will come soon. And then maybe the second one that we say, that's the first one. And then the second chunk that we send, we say, here is the second minute of the call that I sent you earlier. Update any information any assumptions you had. Because not only are we sending it context in the form of a prompt, but it already has the context that it can store from the previous one.
Okay.
So, for example, if in minute 1 somebody says, "Oh, my address is 123 Main Street," and then in the second minute they say, "Oh, but actually I had this thing mailed to 456 not Main Street." I don't know, another Sesame Street. Um, it can then say, "Okay, I'll go back and update that." And so the question is, can we experiment with, does that mean that when we send the final minute as soon as the call ends, that going back and rethinking things that the LLM has thought of in the past, or rewriting previous data, will that be faster or slower than had we just sent the entire transcription at the end? And I don't know. Different models are going to behave differently, right?
Yeah.
But the point here is that I want to hear from you, like, this is something that we can measure. We don't have enough information to make that decision now, but here's things that
Okay.
I would look into.
Okay. So, yes, all of those things and all the pros and cons you just said
Yeah.
for the LLM.
Right. Which also then there's the question of ROI, right? Because let's
Mhm.
say sending for a 30-minute call, making 30 LLM calls, or maybe we cut it down and we do every 6 minutes, so making 5 LLM calls. Will that cost significantly more than making a single LLM call at the very end? And is that cost enough for us to say maybe we loosen our SLO during or our SLA during high volume times?
That can be like an A/B test thing that we can do.
Right.
Like we go in, test, see with different models. Maybe at first we start doing every minute, then as a call after it reaches like 5 minutes, we go okay, maybe every 5 minutes now, and extend that out. But yeah, I don't think that kind of fits in the diagram, but it's something I can discuss with the interviewer.
Exactly. So look, there's three places that we can speak from in a systems design interview, or really any interview. The first one that we prioritize is speaking from experience, meaning, well, in all my work with LLMs and sending audio transcriptions to LLMs, I know that this is the right way to do it, which is great if you have that experience, but
Mm.
that's like unicorn level for something like this, maybe. Maybe. Um, the next level down we would that we can speak from is knowledge, meaning I have read enough about this, or I've seen this happen at other companies, or I've done something that looks similar with video or whatever. But like speaking from knowledge. Now, people get stuck here if they don't have experience and they don't have knowledge. They get stuck. The next level that you need to be able to default down to is logic. And as an engineer, logically, how would you approach this? Well, logically, you said, okay, we can send chunks at a time for audio to the speech to text audio transcript. Now, you told me previously you've never worked with transcribing audio, but I noted, okay, but you just intuitively, logically determined we don't need to send the entire audio file to it at once. We can send chunks and stitch it together later. Love that. Now, logically, how can we do the same with LLMs? Logically, how would we experiment with that? And so just
Mhm.
talking about, I don't know now because I don't have enough context or we don't have the information, but here's how we would test it out. I love hearing that when I'm interviewing somebody because that tells me that you're not going to just sit there and be like, I don't know. It's, I don't know, but here's the tools that I have in my toolkit to help me figure out how we can make this work. And yeah, we're going to have to A/B test, we're going to have to measure, etc.
Okay.
Cool. Let's see. Do I have any other follow-ups for you? Um, well, we talked about scaling. I think one area where I would have liked to hear a little bit more is you mentioned like auto scaling, but I think that what there's nothing wrong with saying auto scaling, but I would love to see. I love when I see people say more than auto scale, right? Like
Mm.
for example, logicking through the product side of things, like you said, this is a call center. One thing, you being me, one thing that we never got into was asking me, like, well, what kind of call center? Or at the very least, what do we expect for the usage, the intraday traffic shape? What I mean by that is this the type of call center where we can expect 24/7 calls? Or is this the
Mhm.
type of call center where we can expect, I mean, are we even open at 3 a.m.?
Yeah.
Or could we just expect near zero from at 3 a.m.? And typically what we see is like, you know, certain things have spikes. Maybe at like 9 a.m. everybody gets, or 7 a.m. everybody gets up and they want to make this call before work. Or maybe it's something where the call service is actually servicing businesses, so they expect to get more calls during business hours. And so kind of talking through understanding what those peaks are, knowing if we can auto scale aggressively based on saying, oh, we know we're going to get a peak at 9 a.m. So we, instead of having cold starts, we use Kubernetes to automatically provision, or we use AWS to call our Kubernetes Helm charts, blah, 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 all the words to automatically provision boxes. Um, those are some nice things to hear about.
Okay.
So the last question I have for you
Hmm.
is, how would we measure the health of this system?
Measuring the health. So we're going to want to measure how when things go in and out of every microservice we have,
Mm-hmm.
and knowing something fails and at which point it is in that in this system.
Okay.
So we can add some analytics tools to do that, and that probably handled by the orchestrator in there, because that will definitely be getting all the statuses of each service. And depending on that information, we can figure out what the health of the system is.
Mm-hmm. Cool. What specific things would we be? Well, let me back up.
Hmm.
What would we use to measure the health?
Um, I would say naively, we would be measuring, is there, after a call has ended, how many summaries are we getting within our specified time frame?
Okay.
That's like first thing. After that, if we want to go deeper into that, we have to measure, okay, if we're not getting that summary within that time frame, where is it getting blocked up? Is it getting blocked up in the ingestion versus the speech to text versus the LLM? And we can probably add some, with the logging that we're adding, use the time markers to figure out exactly how long each step is taking,
Okay.
um, or if it's just flat out failing in any of these steps.
Great. So I like that answer. It's not the answer I was looking for,
Oh, okay.
but it's okay. It was a vaguely worded question on purpose. When I said what would we use,
Hmm.
what I was looking for was more along the lines of like technologies.
Oh, it's like Datadog, New Relic. You could be using um, AWS CloudWatch. You can also use
Mm-hmm.
Plant Technologies.
Yeah, those are the types of things that I would expect to hear. Um, Somebody who's a bit more SRE, I would want to hear them start talking about things like setting up Prometheus to store the data using Loki to inject, kind of getting
Hmm.
more into the guts of like those technologies, like a Grafana Prometheus type setup, or like if you're a bit more old school Elk Stack, fine. But yeah, I think just saying, hey, we can just slap Datadog on this because why over engineer it?
Hmm.
And then the follow up was going to be like, what specific things would we be looking for? And yeah, so we want to know about failure rates. We want to know about any sort of anomalies as far as latency, or, we want to be able to measure against our SLAs and our SLO. Again, an SLA is our service level agreement. So that's external. That's what we
Hmm.
basically say. If we don't hit this, we will refund you money. And then our
Hmm.
SLO is internally going to be more aggressive, what we actually are aiming for, because we don't want to be just at that level where we could be losing business or losing money. And then, yes, we want to be tracking those. We want to be tracking against things like, 99th and 95th percentiles for latency, for error rates, any, 500s we want to, and 400s, we want to be able to see all of those. And then, of course, we're also, I think we didn't really talk about this, but like the LLM, there's an assumption that the LLM would be like an external provider rather than ourselves.
Hmm.
And so, of course, we want to, I think a lot of companies fail to monitor the health of external services. There's this trust that the third parties will just update their status page.
Oh,
Um,
agreed.
but I think it's also good to just have some sort of like tracer bullet, something that just kind of like, or like a health check, just to make
Hmm.
sure that that's working. Um, cool. Good job.
Thank you.
This is a cool cool little design you made. Do you have any questions for me before we wrap up?
Not really. This was a fun problem. I've never like designed anything that has to do with like media, and so all of my knowledge basically just came from like, how do I use media, and how do I want
Cool.
to be able to do things?
Yeah, I think at the end of the day, the important thing to remember is that it's all ones and zeros. And what I
Hmm.
mean by that is we think, the first time that I started working with audio or video, I was like, oh my God, I have no idea how to work with this. And somebody said, it's just a lot of data. It's data, but it's a lot of data. So you have to handle it differently just because it's a lot of data. But you still need to just think of it as, like I said, data. Because you can just break up audio into chunks and send it over HTTP just like you would anything else.
Hmm.
Um, and so I think you did a really good job of. I like that you brought in your personal experiences there, logicking through things if you either didn't have experience with it or just didn't have that concept at your fingertips. You were able to kind of logic through and find ways to access that. And overall, I think what was really important was the flow of this interview was really nice. When there were moments where I had to give you a little push, you took it and ran with it. You clearly had fun with it, which is actually really important if I'm interviewing somebody for a system design and they just like are approaching it like, their math test and they just want to get through it. Then it's not really going to be somebody who I'm going to be excited to work with and excited to solve these types of problems with. So I think you brought a really good energy to the interview, and you also did bring a lot of really good experience and knowledge and logic. So yeah, good job.
Cool. Thank you.
Personally, I think that the candidate did a really good job. One of the things that I really appreciated was how she was thinking through different technologies that she might not necessarily have had personal experience with, but understands the underlying principles of. For example, how she was talking about TCP versus UDP to transfer the data. That is first principles thinking, and that's what we want to see in interviews. We know that not every interviewee is going to know everything. You can't experience everything in your career, and you can't keep all that knowledge in your head, even if you have learned something. But what we want to know is that you can figure it out by relying on those first principles. First principles are the things that you are taught when you become an engineer. How do computers work? How do we store data? What are the different types of layer 0 and layer 1 technologies that we use for transmitting and processing data? If you can retain those core building blocks of information, those atomic pieces of information that make up software engineering, you can logic your way into an approach that will fit almost anything. Another thing that I really appreciated about this was that we did take the time to talk about how would we experiment. For example, this is an abstract, this is a hypothetical problem, and there's no real data that we can actually try things out with. We're not always going to know in a software engineering project what is the best approach from the moment zero. But instead, we can set up a couple of experiments, a couple different approaches, and think about how we're going to monitor and how we're going to determine which approach is the best. For example, when we were talking about the size of the chunks and how we were going to split that up, work through the pipeline of transcribing and summarizing the audio. So thank you again for watching. I hope you found this just as informative as I did. If you have any other questions, feel free to drop them in the chat. Don't forget to subscribe, like, share with your friends. Don't forget to check out NextPath Mag. We have a Substack. Also, if you are in engineering and you're looking for a new job, or if you're looking to upskill yourself as an engineer, as a leader, as a manager, as an interviewer, reach out to NextPath. I, as well as my staff of experienced coaches who have backgrounds in software engineering leadership, would be thrilled to hear from you and to work with you on your journey. Until next time.